Hello.
Hey there.
How are you?
Yeah. Not bad. Just still haven't quite had my breakfast yet. I'd get up. The capstone projects for the students is like, it's 5:20 a.m.
Oh, okay.
Yeah, like it's.
Do you have to go somewhere, or is that on Zoom or something like that?
Yeah, no, it's on Zoom.
Oh, okay.
I think some, they have a local site in Nigeria.
Okay.
In Lagos.
Yeah.
But I just got my students kind of report, and so my students are all from Ghana.
Okay.
Different universities in Ghana.
Right. So yeah, we had one meeting this week. That was the DevoWorm meeting, and that was I think just Susan and I were there, and maybe Morgan I think was there as well for a while. And we talked about a paper where they used COMSOL to model this process in development called invagination. So they were modeling the cell sheet in a ball, and they were modeling it folding inward. And we went through the mathematics of that and what they were doing. And Susan, of course, has been working on this tensegrity project. And so she tried using COMSOL for that, and it didn't work very well. So I wanted to go over how they implement a model in COMSOL for developmental biology, because usually COMSOL is an engineering tool to use for building mechanical systems or other types of physical systems that aren't biological. So it was interesting to see how they did that. And then we talked about this paper about phase transitions and sort of information processing in cells, or in migration. It was actually cell migration and development. So we had a little discussion around that as well. So that was a good meeting, and that's on the DevoWorm YouTube channel. Didn't have any other meetings this week. A little bit of discussion about following up on things from meetings past, and Jesse's of course going to talk about his he did a couple of things this week we'll have to talk about. There's a couple of plans going forward. Yeah, and then we've been working on this Active Inference Institute Symposium, and it's coming up in the middle of November, like around November 13th or 14th. And I've been working on some submissions for that. And we still have, so I'm kind of on the scientific advisory board, so I'm doing a lot of work with Daniel, preparing for things. And so I guess there's a plan to do one talk that's kind of related to the last year's talk, and then another talk on the open source sustainability stuff. So that's, I don't know if we want to invite someone to give a talk like we did last year. Because last year what we did was we had the cybernetics talk, the open access, open science talk, and then we invited someone. So if we want to invite someone, we can do that. I can set it up, what we can do.
Yeah, I mean, I've got a lot of emails that I need to get out, and I don't know if well, I mean, I think a couple of months in advance is
good enough to see if Jarek is interested. He can say so much about open source.
Yeah.
I'm trying to think about other people though. I mean, in the sense that, like, who are the new open source? I mean, as well as like the open source sustainability is such an interesting project that is kind of more than open source itself, right? Or yeah, just trying to think about who, or if it's worth connecting with kind of like a person who's thinking about maybe like or maybe somebody like the Turnway community manager or something like that. Like somebody who's thinking about kind of like,
what is the Turnway community?
No, it's the Turing Way.
Oh,
like Alan Turing. Yeah. So it's the British Data Science Institute. Yeah. Okay. Well, this is the Turing Institute, right? The Turing Way is a project that was started there. That's an open source book, right?
Yeah.
But it's an open source book of best practices, and has become kind of a community of community builders, right? So, and I'm pretty sure that they spawned, of the many things that kind of like this community of community builders built. Open Life Sci, I think, is a community that they built that trains new life science researchers. I mean, and they've definitely got like a software carpentry model in terms of, the trainees become trainers, kind of graduate.
Right.
And anyway, like I don't know. Maybe Jarek is just kind of, tired of always being the voice of the open source community.
Yeah.
And I mean, I've as well as like the project is also well, I mean, I'm kind of curious, like how, again, like you talk about the project as being more than like a software coding, multi-agent coding system, right? Because that's not the purpose of the project, right?
Right.
And so it kind of, in getting a speaker, I think you'd want to be kind of like more aligned with the project's kind of greater goals.
Yeah.
Which, again, not to say that that's not Yarek's. Like, again, he was my inspiration in terms of open source project management and kind of community development, for sure.
Yeah. Yeah, I think that would be good. Because the greater goals are kind of like, And it's like giving a talk about the different technical pieces that have been put into place in the last couple of years. Because, we've kind of built upon the reinforcement learning aspect. We've had probably a good 3 years of development on that. Last year we did large language models, and that's interesting, but, it's kind of another piece. And then there was the, back in 2022, if you remember Brian McCorkle's work on active inference and how he did some of that. And then those are all pieces.
Yeah, where is Brian now?
Well, I guess he's doing his art and doing other things.
Out making music?
Yeah, making music.
Yeah.
Working, I guess. But anyways, and having and those are technically interesting, but having the overarching goals, and then of course having someone speak to that outside of that project, like what's the greater utility of this?
Yeah. I'm just gonna put on my camera for just a second and have a bagel.
Okay. All right. All right. So Jesse sent me this. I think this is like I don't know what this is. It's a draft that he's working on about, or maybe he's doing a post on this. This is living things are not machines. So this is this paper that we reviewed, I think in a cybernetics meeting. And it was this with Josh Bongard and Michael Levin. And this is the Foresight Neurotech seminar where they reviewed this paper. And
they didn't really review the paper. They just they brought it up. In the it was a fireside chat that started. I forget the host's name, but he's kind of asking them to speak on their work, especially their work together, and I think it was Josh though who mentioned the well, honestly, I can't remember, but that it's machines all the way down.
Okay, yeah, I remember that.
To get playing on two lines, right? So somewhat the turtles all the way down, but also I think it's from that paper. There's plenty of room in the middle, I think is their paper that plays on the Feynman.
Right.
Yeah. But it was more. It was as opposed to like covering a paper, it was more just speaking to that particular agential multi-scale agential material.
Yeah.
Yeah.
So this is kind of, I guess Jesse's doing a post on this, kind of digesting some of what was mentioned in that event, and then reflecting on, the paper itself. So I think it's interesting. When he comes by today, he will probably talk about that amongst other things. So we'll see.
Yeah, for sure. Excuse me. It was good. They were both speaking very high level about their work.
Yeah.
But I did get to. It's just like my one goal was to ask. Well, and then Michael left at a certain point. I wasn't actually looking at the clock, but like half an hour in or something like that. Michael left and Josh remained. So I did get to ask Josh. My question was, where does our how can we bring more biology into the kind of computational simulations that that they use for their xenobot and anthrobot kinds of predictions, because I mean, I love his evolutionary robotics course, and and he brings you through, let's not say a traditional robotics program, but certainly a traditional computational robotics program, in the sense of he starts you very, very early with doing computer simulations of robots, right? And so it's almost a computer simulation of robotics class. But then once you get to some sophistication with that, he does kind of talk about an advanced applications, and one of those is just the anthrobots. But the anthrobot simulations are they're very they're a very crude biological simulation, right? I mean, it's like it's I mean, there's a reason that you kind of only get the motility prediction, because that's the simulation environment that you're working with kind of only does that. Right. I mean, this is an environment where you start the class by like how do I add an axle and wheels, to a basic robotic form, right? I think it'd be anyway. I mean, I shouldn't say. I only think I got into like the 20th lecture or something like that of this year's course, but I don't know how much we get into. His answer to my question was talking about more biomimetic simulations and biohybrid designs, which again somewhat speaks to a very, to some extent, traditional robotics like work, right? Where it's just like like you're still building with parts, not machines. You're building with parts, and you're making something that perhaps moves like a centipede, or you're making machine robots that are insect-like or something like that, right? Well, anyway, I mean that again, it's well suited for the simulation environment that he has, and I want to see more because I know some of Michael Levin's software projects. It's like I wanted, basically I wanted to see. Yeah, we're also thinking about CompuCell 3D or something.
Yeah.
But those would honestly be more Michael Levin's in terms of people familiar with biology, to actually be working with those tools or thinking about how to utilize those tools or I forget if he even gets into kind of soft robotics with like finite element modeling, for instance, like console. I assume he does. I'm not sure. But even then, I mean, well, that would certainly be one way to bring in, physics in an appropriate fashion. But in terms of making predictions about the anthropobot behavior, it still doesn't seem that there's any good model,
Right.
But it was definitely a nice discussion, or it was nice to have them for briefly answering questions.
All right. Why don't we move on to paper? Or I want to move on to this item here. So yeah, I want to move on to this item here. This is something, from the transmitter.
This is Ben Dichter.
Yeah.
No.
And it's called "Should Neuroscientists Vibe Code?" which is, if you're familiar with vibe coding, it's basically where you go and you lean on a large language model to generate code and then kind of put it together and try to get it to work, which is kind of like, how we do things in, with Stack Overflow, just kind of putting together code. And a lot of times that's considered bad practice. And of course, using a large language model is sort of similar, just generating code for it, to sort of, as long as you pose the problem well, you theoretically should be able to get code that works pretty well, and then putting it together. So it's not, let's just say it's not at the pinnacle of software engineering good practice, but it's, if it's effective and useful, especially for neuroscientists who don't spend enough time on software development in the first place, that might be something that's acceptable. And we've talked about how neuroscientists can use software engineering to improve some of the software projects that are used in neuroscience. So, like, they're research software engineers who can improve a lot of the academic software, because a lot of the academic software isn't very doesn't have a very good robustness to it. In any case, that's kind of the frame here of what this is. And of course, thinking about vibe coding more generally, I talk about this in a class that I teach, and one thing that people point out is that you don't really learn anything from vibe coding. In other words, if I vibe code and I query a large language model for code, or if I just kind of get code from other places and stick it together in a program that does something, I've not only created a piece of software that isn't really maintainable in the long term, or it's probably not maintainable, but it's also, I never learn like how I never learn how to program. I never learn sort of how to use better data structures. I just use the data structures I'm given. So it can be, especially for people who aren't computer scientists, who maybe need to learn some things about coding, or experts in that language, it can be somewhat problematic. But anyways, that sets up this whole sort of debate that they have here, which is, should neuroscientists vibe code? And so researchers are developing software entirely through natural language conversations with advanced large language models. The trend is transforming how research gets done, but it also presents new challenges for evaluating the outcomes. That's the point they're trying to make. So this other quote here, every line of code in a research project, whether written by humans or AI, must be attributable to a specific person who can defend its logic. This is what I was talking about with respect to education and in auditability of the code. That, like, if I put together something through vibe coding, I don't necessarily know how it works, and I can't really say, oh yeah, I know why this isn't working, or if someone says this is not processing the data correctly, and this happens a lot in academic labs where you try to do an analysis and you have something doesn't, it might work for a couple of data points or data sets, but then when you try to apply it again, it doesn't work because it hits some exception in the data file or something, and then you spend a lot of time trying to find a solution to it. So this is a problem. You want to be able to defend the logic of the program. You want to be able to go through line by line and explain what's going on. You want to be able to validate the assumptions made by the program it's generated. So, in a lot of statistical tests, for example, we have assumptions about the data that go into it. If you query, a large language model, or even go on to Stack Overflow and ask, generate this code to do this thing, it doesn't necessarily care about the assumptions of, say, fMRI or EEG and what those data, what's underlying those data points. Is it a time series? How are we binning things? All those things about measurements don't really hold. And then, of course, you have to explain this to reviewers. So if reviewers point out that your code is not doing what it's supposed to do, then you have to be able to respond to that. So, so there's been this debate about using AI to write essays, but of course we're also applying it to research, and there's this whole other set of sort of standards that we need to develop. So, like journals like Nature have developed guidelines for using AI to write research papers, but not necessarily for working with data or generating research code. And so that's kind of a problem that we have to kind of solve as a research community. Vibe coding is a rather new thing. It was coined by OpenAI co-founder Andre Karpathy, and it's just basically interacting with a large language model and trying to generate code and then use it in, I guess, high stakes situations, because you're you're doing the same thing you're doing with software development. You're just kind of like cutting out the part where you actually do the analysis and thinking. I guess you do thinking in the queries that how you query the language model, but you don't have to think about like the data structures that you're using and the pros and cons of that and all of that. So it does offer opportunities for people who aren't like professional software developers, and so that's the advantage of using it. And so this person says, the implications became clear through my own work. I collaborate with a small team to build AI interfaces for the Dandy and Open Neuro archives, extending standard agent tools to search data repositories and directly access open data sets. The results surprised us. The system could reproduce key findings, such as orientation tuning in the visual cortex, directional selectivity in motor cortex, and place field properties in the hippocampus, at the level of a competent first-year neuroscience graduate student. Whether it can discover genuinely new phenomena remains uncertain, but its ability to rapidly validate established results is already transformative. So this is, kind of a sort of a victory for this method, but also, there are, of course, some challenges. But they're going to talk about sort of the victories first. So it can reproduce things. It can reproduce results. The democratization extends far beyond reproducing textbook findings. Spike sorting, which traditionally required deep experience in signal processing, can now be accomplished by any researcher who can describe their experimental setup. Building biologically realistic neural network models, once the domain of specialist programmers, might soon be accessible to anyone who can articulate their theoretical framework. So as long as you can articulate this in natural language, or you can query a AI model in some way, then this becomes possible. It opens up doors instead of creating barriers. The technical barriers that have limited many neuroscientists to descriptive statistics are dissolving, but this newfound power comes with serious risks that our field hasn't adequately addressed. So this is an interesting point. It kind of goes beyond vibe coding to kind of, using tools that allow you to do things like dynamical systems analysis or other types, just basically getting a hold of a lot of data sets. And of course, he works for, I guess, Dandy. So it's, you have that other added aspect of, does neuroscience change when you have access to a lot of data? Because there are all sorts of issues around data set, reconciling data sets and all this other stuff that is, you don't really learn in a classroom. They do have some classes. Computational neuroscience isn't about this. It's about computational models of the brain. Are there classes where you can learn about using computation in research? And that's a problem because maybe not a lot of neuroscience students get that education. Usually you're busy learning all sorts of things about the brain and, things that may be about like computational methods and then other things that you need to know in biology and in psychology and in computer science. You're learning all these other things that are important for being a practicing neuroscientist. Is there room for a class like this? And do people get that exposure, given how central it's becoming? So and then of course this question is, so should neuroscientists vibe code? And then the author says the answer is a qualified yes. Proceed only with the right approach. Okay, so then kind of goes through some of the drawbacks of using AI and benefits of using AI. This goes through a lot of the drawbacks, how AI can feed off of pre-existing biases, and how it can be extremely sycophantic, so it gives you the answer you want instead of maybe the correct answer if you're misguided. It won't tell you that. You have to find out the hard way. And so these incidents reveal a troubling pattern. AI systems fail when we don't understand their training data, implicit assumptions, or decision-making processes. In neuroscience, where subtle methodological choices can determine whether you find a significant effect, this lack of transparency becomes especially dangerous. Okay. And then, of course, there are also reproducibility implications. So he said that you can reproduce research, but then there's also this other aspect of reproducibility where there's this sort of human intentionality behind every methodological choice in a normal setting where you're not using AI. So if you decide to go with a certain methodological choice, that's something you can defend. That's something that you understand and is a standard in the field. So if it's not a standard in the field, it gains scrutiny. If you can't explain it, it gains scrutiny. But if it's generated by AI, we just have to kind of accept any kind of thing that results from that. So it's kind of hard to know, what kind of assumptions the model is making. So consider a concrete example. An AI might choose to apply a particular smoothing kernel to fMRI data based on patterns it learned from training examples without explicit reasoning about your specific experimental design. So that means that you could have the situation where it's doing added data analysis that violate the assumptions of the statistical method or violate the assumptions of the data set. And so that's a problem. And of course, if you don't know that, you can't defend that choice because you didn't make that choice. The documentation challenges multiply when we consider prompt sensitivity. Research has shown that subtle variations in how you phrase requests to AI systems can dramatically alter outputs. Analyze this neural data for place cells or to identify place cell properties in this data set might yield different statistical approaches or parameter choices. Unless we maintain detailed logs of every interaction with AI systems, including failed attempts and refinements, we're left with analysis pipelines whose provenance is essentially unknowable. So this is, we build analysis pipelines for a reason, and it's going to be undermined in this way. So it seems like it's pretty, those are some pretty big qualifications, and depending on, how you build your pipeline. So, in other words, if you use something like this, you want to be able to know to see if you can figure out exactly how the code is generated. And what I mean by that is if it's doing things that are you don't really understand what the logic is, being able to go back and analyze the code post hoc to make sure that it's something that you want and then refining your queries. So, sometimes there's this temptation to, try to try to do this in the quickest way possible, grab the code and run with it. And in fact, what you probably need here is an iterative design process where you not only design your kind of code base, but also design the queries that you're using to get code to add to that code base and then use that as your analysis. So it might take a lot more work than writing code by hand, or it might be a shortcut, but you need to have these, this added layer of scrutiny or auditing to it. So AI tools can be transformative, but they require the development of new forms of literacy. Statistical understanding becomes even more essential because AI can implement any test you request without determining whether it's appropriate. And so domain expertise matters more than ever because the quality of AI-generated solutions depends heavily on input specification. The ability to read and critique code becomes essential for identifying subtle errors that could invalidate entire studies. And so this is where you get into the responsible adoption and the accountability, and people who embrace this transition thoughtfully will have tremendous advantages in tackling the field's biggest challenges. And so, yeah, that's the article. And so I don't know what you had to say. I'm sure you have a lot to say about that, Morgan.
Yeah, for sure. So one, I got to meet. I got to see Ben at the Allen Institute Open Science Education for undergraduates, or for undergraduate education, Open Science for undergraduate education. And we talked some about, so if you want an example of their work with Dandy Archive in particular, the NeuroData Rehack is all available on YouTube. So they just did a coding, a kind of a hackathon. It's Rehack because it's using Dandy Archive data to do secondary analyses, right? So these are all published data sets, but can you use these published data sets to have some other conclusion or focus on a different question or something like that, right? and it was very much like for grad students, postdocs, right? So I wonder, and I know I posted the videos on Neurotech X Slack. I'll find the link in just a second. But I wonder if this was a session of that, in the sense that, like, this was definitely a meeting where I think it would have come up,
Right.
Totally related to that. Hey there. Yeah, I mean, and kind of related to the software, the open source software sustainability. Some of the, well, I should also say that at Frontier Tower, there's a lot of people who absolutely are, in the cult of vibe coding. And like a lot of people whose first search operation is to ask an LLM, right? And I'm just kind of I mean, I'm not making fun of that. It's it's just like there's definitely a great need to understand these outputs. But the bigger issue is the bigger issue, or something that's coming up a lot, is that, like, vibe coding should be done by a swarm of agents.
Okay.
And that to me reminds me of the open source sustainability, at least, in terms of treating it like a multi-agent problem, where you give the system more different defined roles to address some of the issues that you mentioned, or Ben mentioned, in terms of documentation and kind of to some degree testing. Again, like how to well define those rules.
Yeah.
Going in is another question, but it's something that we should talk about. The other thing I wanted to mention was Russ Poldrack. I think I've mentioned this before, but Russ Poldrack is writing a book right now that is called something like Better Code, Better Science.
Yeah.
And he's like, he's been posting. So if you check, these days I try to use LinkedIn more than X, Twitter. Can't fall into calling it X.
Yeah.
He has posts. He posts chapters of the book, and his student Chris Kurlowski. I'm not saying his name right, but our postdoc, I forget now works for Anthropic.
Okay.
So I believe this book is using Claude.
Yeah.
I'm not sure whether we should consider that an endorsement, but I'm sure you all know that this is one of the things that Anthropic is definitely trying to market, or trying to differentiate, I should say, their products in terms of code generation. So I think it would be I would love to do a real let's get his book or let's get the extant chapters and see, so it would be nice to get the guy who started Open Neuro, who's also writing a book about this, as well as that when I talked to Ben at this symposium, he was very down to do events with Neurotech X, or we could do something for undergrad students, to I would love to show them how to do something like he describes in terms of take a Dandy archive data set and do a rehack where you demonstrate some sort of predictive coding response, or
right.
like that again, like showing undergrads how to do a kind of first year grad student work with quality would be cool.
Yeah.
And with again the caveat that you're not asking them to keep doing it that way, but both showing them what these tools will be able to do in terms of augmenting their work, as well as just how to navigate this new world, right?
Yeah.
And sorry, I was gonna say something about that. So generating that. There was one more thing about that. Well, hopefully it will come to me, but I think it would be really valuable to it's showing them how. Well, sorry, that's what I was just going to say. Was it can be hard to give students something, example code to look at sometimes, and this is potentially one way where you can generate example code and then actually spend the time where you're just taking it apart, not just kind of blindly using it or treating it like a black box. Better potentially as a way to get across concepts. It's another way to get across concepts that's not just kind of starting with the language primitives and trying to build up. Anyway, and yeah, let's definitely have this as something that speaks to kind of like the open source software sustainability, in terms of its multi-agent, as well as this. Sorry, and then the Allen Institute Open Scope program. So Jerome Lecoq was talking about. He says that he's noticed a lot more quality code showing up in repositories.
Okay.
And he thinks that it's LLM generated.
A lot more quality code?
Yes.
Huh.
Yes.
So like against the downward pressure, but a lot more like advanced. I wonder if it's probably like robust and like.
Yeah. so I too would like to know more. I mean, again, I hate to just parrot
Yeah.
the statements of the vibe coders, or the people talking about vibe coding when I have never touched an LLM. Right? So I don't, but I I'm thinking about, like, is it Simon Williamson?
Williston or something like that.
Yeah, you know what I'm talking about.
Yeah.
And it's like, and he's SimonWilliamson.net or something like that. Anyway, he like, wasn't he like the original WordPress developer or something like that?
I think so.
Something like that. Anyway, there's definitely expert coders who can use these tools in productive ways, right? And so certainly there's people saying like this is like the income inequality tool of coding, in the sense that, like, people who don't know how to code will be producing slop, and people who are really know when to use it and how to use it will be making themselves more productive. Again, that I feel like I'm parroting people who absolutely believe these are game-changing tools, but I don't know how much they have experience with them. So I think it would be great to do an event. I think it would be great to get into Russ's book, and like Russ has always been a coder scientist,
Yeah.
So I'd love to see how he's using them. And yeah, and the other thing is that this connection program that I'm doing, like there's definitely need for more tools for teaching in and I've got some issues that I think can be solved technically, but like we're not doing them when, especially with these students that are in Africa with network connectivity problems and compute resource problems.
Right. Yeah.
That I feel like we've done a bad job of kind of like adapting tools to better handle their needs. So I think a lot of opportunities here, and not just to like replace coding or something like that, but to like think about teaching in new ways.
Can I think I missed it. I'm sorry. What's the connection program that you're doing? Like the
that's just why I've had to skip a couple meetings. So that's teaching. We're teaching computational modeling of MRI, or it's like mostly MRI, although PET as well, to students in Africa. And it's been they're very distributed too, right? So it's not just that they're they're not all at the same institution. They're all at different universities. Like, so I just found out today or last night that like all my students are at different universities in Ghana.
Oh,
so
nice.
They're not actually able to all sit in the same room together, And so like when we're talking on WhatsApp or Google Meet, like they're having all the same, like it's not just me being really far away, but like they're getting laggy results, like for hearing from each other, and yeah.
I would like to connect you with somebody who I don't know how it works right now, because they're in a slightly different field, but she's from Ghana, and I worked with her in the past about developing educational capacities for people in Ghana.
Okay.
So, I'm sure she might have some insight, or like at least help, or like at least support or cheer it on, or like find something that would benefit you all there, because that's like was the OG cause for some things for her. So I will make a note of that. So
Please.
but yeah, go ahead. Sorry.
Yeah, no, it's just, and so Russ is, it's like, I assume a lot of Russ's code, better science. I assume these are going to be neuroimaging related. I could be wrong. But
I have a whole bunch to say about, and we don't have to. I don't know if Bradley wants to go with this stuff, but like I've been dealing a little bit with the LLM and vibe coding, and it's real interesting in terms of develop. Like I think there's two very broad like things happening. One is like the immense ease of conceptual exploration, and how like being able to just structure, kind of like Andrew Ning, like don't worry if it doesn't make sense. Don't worry about the code. It's like what you're getting at in the what is happening sense is very easy in some ways, and much it helped. I appreciate the rapidity of that, because I don't know, I haven't really been. I'm not a teacher. I'm not a code professor, but like that's fun. But it's very different from what is the code doing,
Right.
and are you know how to do any, like here's the output, and the output's fun, but like are you just trying to get like where's how much do you need to go on the internal understanding of making the code, or the language, or reviewing it, or just kind of pressing the easy button at the L, and like, I don't know, try again, like games like, well then do this, and like I've been there. I have used LLMs for different kind of study and everything like that, and you have to be very, very, very careful. And I do think it's for people that are like this search is the LLM search. Yeah, so that's the whole. I'm very to ground this and maybe move on to segue to what I really want to talk about next. I'm very interested in those topics as well. I would be interested in supporting events around how do you do the code. As I think I've mentioned before, I'll say it here again. You may not have been here for this, Morgan, but I have answered the call of. I'm a longtime member of a particular group that puts on some events for early career folks, and one of the things that has really came up this year, there's basically an open call. It's like saying, hey, all of our students and potential people coming to the event are like, what do we do about Gen AI and jobs? And what do we do about the impact on the people that are just coming out of college and early career stuff to get the entry level stuff? And this maybe isn't directly related to that. In this learning how to do what I understood the events might be around isn't quite the same as that. But I think there's a lot of overlap there. So I'm already doing a lot of programming about this, in the sense of kind of knowing what to advise others, early career folks on about it. Like I have my limited experiences, and I want to start asking basically everybody here. And I'm over the course of the next few months, I'm going to try to be understanding like what is, what to do and what is advice and what should people know and how to prepare as best as possible, because so more about that later, but interesting stuff. And it looks like I came in and we're discussing the article. I don't know if the article is or could be shared here again.
Yeah, the transmitter, Ben took the transmitter.
And then we had a discussion.
Yeah.
So
It's called Should Neuroscientists Vibe Code is in the transmitter.
oh, okay.
Yeah. So this is an article on kind of a debate about it, but it's a one person debate and like just talking about this person's experiences with it.
And I put in the MICI 2025 meeting just because I was talking, or Stephen Alward who's like was like a long time kitware principal, moved to NVIDIA, right? Wanted some of that sweet GPU money, and he was talking about doing an event where people try to use LLMs to take previous MICI conference papers and code them, using with CUDA, right? And like get a 2024 paper working as a CUDA, so not just implement, a registration or a transform or whatever, but like GPU parallelize it, and which is a kind of like a specialized C++ programming, right? And my response to that was like, to some degree that's not crazy, or that if you had the right test data sets, right, and the right the right procedures around it, like you could absolutely be using it to generate some of those key operations, and just thinking about how to have enough test cases to validate the tool. Anyway, I would like to see it like a lot of the connection people. So connection's just this program. It's in a larger group called Camera, which is really about democratizing MRI in Africa. Mm-hmm. And a lot of camera people are definitely going to be at MICI. Like the head of the program was talking about seeing people in Korea. So I would love to, I don't know, think about that next weekend. So it's like the 23rd to the 27th. And I I was just thinking about it because, like, again, like Frontier Tower's full of a bunch of vibe coders, right? So I'm like, come, I'd love to do an event where it's just like, okay, come, use your prompting skills, generate me some CUDA code, and and let's test it out on medical imaging data sets. Anyway. That would be a cool event. And we might be able to get we might be able to get NVIDIA support in terms of, like, if I said to Stephen that we were doing that, like, hey, can you give us like NVIDIA GPU cloud access for, a day or something?
There you go.
All right. So yeah, thanks for that discussion. That was a great discussion. So yeah, I see that when I was doing the article, Jesse and VD showed up. So welcome. And so I don't know if VD had anything, any updates you wanted to give before we move on.
Hello, can you hear me?
Yes.
Hello.
Yeah.
With my university exams just got over today. So I mean, I think I can look at other stuff, maybe go through GitHub, see what's happening in the world, what other people are doing, something like that. Yeah.
Awesome.
That's why I joined this. Yeah. Yep.
Well, that's great. Yeah. And good.
Yeah, and like I think I texted you and Jesse before my exam started, like, how should I continue in order, and like what can I do? What can my goal, like what role can I play? Something like that.
Yeah. So yeah, congratulations on your exams. Hope you did well. And
Thanks.
as for next steps in the lab, we're working on a overview of open source sustainability for the ActInf Symposium. So you might want to be involved in that. We have other things going on this fall, different meetings, different things. So just we'll keep things updated in the Slack, or we'll try to do things through the meetings where we kind of try to solicit people's involvement for things. That's usually the way it works here. And so, if you have any ideas of your own you'd like to pursue, if you'd like to, take your GSOC project and do things like, run some simulations and, like we can look at the results of that and maybe, publish a paper on that. Or we still have to update the open source sustainability technical paper because I have that to kind of update, and it hasn't been updated for a while. So yeah, so we have a lot of things we can do, and it's just a matter of like getting them done.
Yeah.
So I was thinking if it's like about my you want to say something, or can I continue?
Yep. Go ahead.
So I was thinking if it's about my GSOC project, it's about Sustain Hub, then if I really want to continue to a big extent, I can just do GSOC again next year and utilize the summer for that. And meanwhile, I can collect some ideas about how I can extend my project then. And then now, like if any other help in ORL, if there's any project that they are working on, any research, anything like that. So something like that.
Yeah, I think that would be good.
Yeah.
You can do GSOC 2 years in a row. As far as I know, you can do it twice. We had someone who did it twice. So that would be I think good. Yeah.
Yeah. That was Himanshu.
Yeah, Himanshu.
I would basically just do a nudge of, it's really up to you in terms of if you particularly think focusing on Sustain Hub is really good for you personally, professionally, or otherwise, just keep working on it all the way through. Like you don't have to wait. It's your show. But if you think there's other things you'd rather be doing, do that. You've been in the lab for a while. You have the ability to center what you want or make your own projects, or like if you want it, like again, I don't think this is what you want to do, but as an example, you could make you could build out, okay, Sustain Hub is this thing, you could make an adjacent project, you could make a center for this. There's even stuff in the lab about like computational modeling and a lot of things in the closet, things that are just in the archives of like adjacent stuff. So what I would suggest, I understand you're kind of asking us somewhat, and that's fine to do. I would also suggest tell us some specific like areas of interest that you have, because one, there's probably excuse me, there's probably some connection to those things. I'm coughing suddenly. there's probably an existing connection to those things. Or if not, we can support you in developing it further. I think it's kind of like you're you know the ropes somewhat here, and you've demonstrated the capacity and quality to do things. So you have the reins to do what you want. And outside of this moment, like if you want to talk with Bradley or with me or whoever, if you want to talk with us, like, hey, let's strategize about for my career or for my personal interests. I'm really interested in doing more in blank. Let's have a talk about what that looks like. I would just say, like, let's do that. Because I think the real question is, you know, if you just want to be told what to do, we can tell you, hey, work on this. But I tend to advocate, and that's what you get in a lot of places, I tend to advocate for let's find an alignment of interest and opportunity and what's going to matter to you and matter like to your future. That's my 2 cents on it anyway. So
Right.
yeah, but yeah. Let's like I would basically say think about specific topics or targets or things you want to do more of, and we can discuss like what would be a new project for like this term, or like if you're on board for like the rest of the year, okay, let's focus on this the rest of the year, and we're happy to identify that. So yeah.
Yeah. And of course,
I'll do that.
okay. And of course, I did, in going through some of these things for the active inference symposium, I noticed that, well, I've had this idea for a while, but like extending what we're doing in open source sustainability to the things we're doing on computational agents. So we've done a lot of work on like MetaBrains and Braitenberg vehicles, and having kind of because we've done a lot of work on reinforcement learning in particular through open source sustainability, using that in conjunction more with the intelligent agents or the computational agents rather than just limiting it to open source sustainability. So there's a lot of interesting stuff here I notice with sort of like learning and the stuff with the large language models, of course, and some of the stuff with reinforcement learning, even where we were dealing with like complex tasks. So it's like you're generating a task, you're defining it, and then you're having agents like kind of interact and solve tasks and that sort of thing. And then, of course, there's always this issue of like the swarm intelligence or the collective behavior. And I think we had someone who had proposed like a couple years ago a GSOC project where they were going to do like something with collective behavior and open source sustainability. But like, of course, we were doing the things with multi-agent reinforcement learning, and that's sort of another theme in reinforcement learning. And so that area is, that's of course where you have multiple agents doing reinforcement learning tasks, and that's something that could be developed as well, or we packaged in a different way. So there are all sorts of opportunities, and we have code all over the place, basically. So if it's like anything that you find would be useful to research, or even just to like, bringing it into new uses, I guess is a good way to think about it, then that would be welcome.
Yeah. So I'll I think I'll think about what I want to do. I'll be sure about that, and then we can have another discussion.
Yeah, and that can be in Slack. It can be a private meeting that's like, hey, can we just talk like, for Friday on some other time. Bradley's busy with a bunch of things. I'm busy with things, but like we can find a time to just have like even a 30-minute, a 10 to 20-minute discussion of like, hey, what interests, opportunities here? How do they align? And let's do something. There's a lot of things that are kind of, again, these meetings are so tough because we don't really talk about everything that's going on in the lab all the time. So there's actually, we might be due for kind of what's going on in the lab in fall 2025. You know, that's something that maybe should be written out or a small video on that at some point. But there's a lot going on, and even in my own sense, my own self, there's one thing I might talk about soon, and I don't know what you want to talk about the rest of today, Bradley, but there's a few updates that I have and a few events that I would talk about too that are kind of all around these same clusters. But Vidi, if there's like anything you want to say before we move on to other stuff too.
Okay, you can go ahead and speak. Yeah.
Okay.
All right.
Yeah, but definitely reach out or like message in Slack in particular, and I'll try to follow up on some things too, because I know some stuff might be relevant, but I don't know. My biggest unknown for you is where does VD want to go? Like I know you have some aspirations for grad school in certain arenas, but you know, what's your destinations? So yeah, let's follow up on that. As far as other stuff, did you want to talk about anything specific, Bradley, or do you want to? There's a few updates that I have for JoPro stuff, and then some of the events that I mentioned this week too.
Yeah. So why don't we segue into Jesse's updates? I had mentioned earlier about like this thing you posted in the Slack about the Bongard and Levin talk or whatever that was. It's like kind of a review of that talk or something.
Yes, I have a draft I can go over for that, and that'll be fun and relevant to a lot of stuff. Right. I think I'll get my other junk out of the way and then go to that, because I'll be like, oh yeah, we talk about this, quite a bit, and a lot of really interesting overlaps there. It was for me, it was fun to write, and I was gonna do like a 3-4 paragraph, and then I read Levin's update, and it's like, oh well, okay, well this is cool. Like it was cool to see him associate. Here's where I stand relative to theoretical biologists like Maturana and Varela. And oh, okay, this is like, what are you doing relative to machine? It's kind of just an update on the machine stuff. But with that, my brief updates are there's also that other event, but I don't know how to talk about that as well. I don't know if you were there for that one, Morgan. The one with Ivan and
Will Hahn, the Echolopta one from like Wednesday or something. I don't remember.
Right. Yeah. So yeah, we didn't talk about the computational philosophy meeting.
Oh yeah, you were there. Wasn't that was at?
It was in front of your tower. Yeah.
You were totally there. Okay. Because like it was to save myself from embarrassment, which I don't have any, but just to it's because the first half of the event was like very a specific set of talks, and then Elon and Will joined.
It was
their LM stuff. So yeah,
it was it was an interesting way to do things, but just to give Bradley and everyone a sense of the backstory here. So Echolopto principal, or Adi applied to be a member of the tower, and and then Dugan, who's the Wolfram Institute, I forget what his position is there, but was in San Francisco, and they wanted to host an event at the tower. Mm-hmm. And this was together with Andreas, who's the co-founder of Qualia Institute, Qualia Research Institute, so CQRI, right?
Mm-hmm.
And although I have some misgivings about anybody, who's not very concrete about their there's definitely a thread of quality research institute work that I really love in terms of computational modeling of multimodal neuroimaging. And this kind of relates to some of like Robin Carhart Harris's work and Morton Kringleback and Celine Adesoy that is, you know, top notch. I mean, this is some of the work that I'll be covering in the second week of October at this Neural 2025 meeting. So Dugan did a presentation on the ruleology, you know, the Wolfram Institute work, and then, you know, there was breaks, and then professors were calling in. So basically, his advisors at is it University of Florida Atlantic?
Yeah, a lot of them are from FAU. So yeah,
Florida Atlantic University. Yeah, so I was trying to accommodate them kind of last minute, but I was really happy, and I'm happy that that Adi's interested in becoming a member, and that so let me just check if I've got a message from him, because I was hoping to yeah, anyway, unfortunately he's going to have to reapply, but that was great. Like they were there, you know, doing events until the late in the evening. So even after William and is it Evan?
William Hahn and Elon Barinholtz.
Elon, yeah, ELAN, right?
Correct.
And but even after the computational philosophy meeting ended, Andreas and Dugan went upstairs to an AI meeting where Andreas was continuing to present. So they didn't leave the tower until, like, you know, in the 9 o'clock or something like that. So that was very cool. Really hoping to have them, you know. So talking to Adi yesterday, like having a, you know, multiple, like say twice a month, if not once a week, recurring meeting that we host at the tower. That and I was super interested to hear that Elon and William are interested in fMRI studies of their work. So just getting to that point of you know, I'd love to see more computational work. I'd love to see more empirical work around these theories. Yeah.
Yeah, I think that's what, and I think it's a mix of, I mean, exactly like that. How would some of that be like just instantiated or done, or what does it mean? And then, you know, I'm very open to. I think I'm not. I say this as someone who is very very vested in being aggressive theoretically about what you want to pursue. So that's not a bad thing to me. But yeah, it kind of, and I think there's a realization of that, and a realization of like, okay, like there's like preprints that I know are being worked on and fleshed out. I don't know how much they're going to be computationally centered, but yes, exactly. And that's sort of where I am too about it, in the sense of I'm curious, like in the meeting, and I think it was that meeting. There were so many this week that they're all meshing in my mind right now when I try to talk about them. There were some things at the end of the meeting about what's next for everyone, and there is a sense. One, I'm very interested in. it's so interesting because I feel like I'm kind of balancing the Josh Bongard, Michael Levin thing from earlier this week, or from later this week, which is like yesterday. Wow, it's yesterday. And this where Michael Levin's he's really trying to do a specific kind of work, bringing behavior, machine versus non in a direction. And a lovely throwback to the behavior purpose teleology paper as usual. And it's this latest iteration of his work in that space. Then you have this sort of hopes of like Elon and Will have this sort of hopes about LLMs are identifying this key language. I was gonna say to Bradley, it's almost like like in our old school meta brain, we have the kind of the lower functioning relatively thing, and then this metacognitive box on top, right? It's almost like they see language as this other layer in the meta brain that the LLMs have solved the I don't want to say topology space because that thing's a little bit more. That's more me than anything they're saying. Like they solve some way of navigating what this layer of contextualization is, or revealed a. It's so tough, and I do want to see more like stuff from them. Like really, I want to see some really juxtaposed clarifications because when I'm trying to do it here live, I don't know if it's me inserting my stuff or not, and I don't want to do it injustice because to totally steelman the effort, I see it as okay. Do I personally, my personal bias, just to declare it, I don't see LLMs as being really smart. I see LLMs as being excellent at extracting statistical coordination of things. What I actually wanted to, as a side, I'm very interested in basically writing something about my phrase is teleological coordination. That's what I've developed from it. And there's a few months ago, a lot of the language in the Echolopta stuff was like language as coordination. And it's like, okay, yeah, like I'm into like coordination. And it's like I'm kind of in between like the Levin's very, very open to like behavior purpose theology reference, that kind of stuff. And like, yeah, like what you're trying to do is coordinate at this level. And I don't know if it's the same level that Elon and company want to talk about what they're doing. So to step back, I'm let's say agnostic about what LLMs do, and I'm sympathetic to. I'll even I'll put on the blacklisted stance of I'm sympathetic to some of what Gary Marcus says about structures of things, and it's so interesting because there's major disagreement. Dan Van Zandt, who is a PhD student of Elon's, is a little more like, well, maybe there should be some symbolic stuff here. Maybe it's not just this thing. So interesting. I would love to have an extended discussion with like all of them in I don't really want to do this, but it would be fascinating to have basically me, Bradley, and Morgan, you two, and Dan and Elon as like almost like a round table, and then someone else like I don't know who, but someone to be like the other juxtaposed point of what not debating about what LLMs do, but like what is the like what's being pinged around in terms of what's the inputs outputs of it, like what is happening and how does it relate to everything else we want to be studying, right? That's all. I have to reply to this person. I just saw anybody to reply to. Right. That's so funny. I'm looking the corner of my eye, I see somebody's name, like, oh, I didn't reply to that person. Anyway, yeah, what's happened there? So to condense, I think there is an insight that Elon has that is useful. And I like the framing of whose problem is the mind-body problem, it's language's problem. Like there's something fun there, but and I want to wield something like that to revolutionize cognitive science, AI, like to do the bigger work at play. Is this thing going to be it? I don't really know, because I don't know enough about what the insight, what is the like movement forward yet. I don't know it in enough detail yet. So I think there's a little bit of like, is it a space that everybody's interested in? Like talks from MIT, what Frontier, we got a lot of people interested in this kind of stuff, but like there's a sort of mountain, like what is it functionally going to do, and so on. So that's kind of that. And I'm trying to find what I wrote, because I wrote a few different notes about these things, as I usually try to do. Oh, sorry. There we go. What do I have here? Also, I did get an email from Michael Garfield about stuff. Well, I've emailed him to confirm it, and we can follow up with him about that stuff here. Here's what I said here. Be curious about, I said, yeah, okay. In the Slack I had, be curious about y'all's take on this. And then I mentioned my metagrowing comment. Yeah, and you want to see more. And then Morgan said what he said earlier about computational examples and the theory. Okay, that's kind of all I have to say for that. I don't know if there's anything else you want to say about that event before I move on to other things.
Yeah. So there's still a lot of ambiguity in the conversation around these topics. That the others that are working in this field, or in these similar areas, who are doing computational work, like a lot of those ambiguities disappear when you see an implementation, and an implementation applied to some sort of data or some sort of process, but what I wanted to just say a bit more about, and also get some feedback on, was the Josh Bongard Michael Levin meeting, in terms of two things that he mentioned. So one was vibration and polycomputation. So I hadn't had a chance to go through kind of like events this week and upcoming events, but events this week, or past week, big one was Earl Miller's presentation at Louis Pessoa. Is that Pessoa? Entangled brain guy, Bradley. I don't know if you know how to pronounce his name. But Earl Miller's got a presentation that I think is super relevant for this kind of polycomputation, in terms of redefining, or kind of like trying to use the multiple frequencies and oscillations in whole brain electrophysiology to come up with a kind of analog computing model that I think is a lot of overlap with the kinds of things that, again, Josh didn't give me enough detail, but he gave me some paper suggestions in this regard to follow up in terms of polycomputation. And I think finding those links between the what Earl Miller's talking about, who is very much in the brain with electrodes, would be interesting, because they're both getting at they're both getting at alternative computational frameworks that allow for an incredibly efficient, incredibly high throughput computational system, which does sound like a good description of the brain. And then the other term that he dropped was this meta robotics, and I don't think I know you said something about yeah. Did you comment on meta robotics with regards to meta brains?
No, basically, I maxed that out already.
Okay.
I was in a very peculiar situation during this meeting, and I was really locked into like probably 65% of it overall. And then I was there listening, and I had other stuff to do, and I was in a cafe, and all this stuff was going on. It's like I listened super intently to like a good chunk of when Levin was there. For those that don't know, Levin was there for basically like 30 minutes or so,
Yeah.
and he had to dip.
Yeah.
And then the focus shifted slightly to like Josh's stuff. And I didn't absorb enough of the meta stuff because it just sounded similar, or is that not similar, but like it sounded like okay, like this kind of makes sense in our existing context for it. But I'll defer to you if you have any like actual insights or.
Well, I've so this was where he was responding to, I think, Mikhail's question, if I remember that name right. But like there was someone who was definitely a roboticist who was asking questions, and it seemed like Josh understood the kind of the greater context of where these questions were coming from, and this is where he was just like, yes, this would be very meta robotics, and it was one of the I think maybe I was still churning on the connections in the poly computation.
I think that's I think that's actually also a fair way to say it. I think I was trying to give myself an out with all this other stuff going on, but like there were some really deep nuggets, and I just hadn't expected to go to, as you can see here on pointing, it doesn't really matter where I'm pointing, as I wasn't expecting. Maybe it was foolish of me, but I wasn't expecting to go into the Living Things Aren't Machines paper that we covered here. Like we I don't know if Morgan was around for it or not, but like we went in depth on that paper and thought it was really interesting, and then also kind of criticized like, okay, this is really new, like this is not fleshed out. And then he drops in the comments, which is on screen.
Right.
I'm very cheeky, like, oh, so like living things are living machines.
Yeah.
And then everybody's like, yeah, that's cool. And Levin's like, oh, by the way, I released an update a few months ago about my thoughts on this. And I'm thinking, so that's just like, oh, I was kind of thrown off by all of this stuff. And I didn't, that happened a couple times, and I didn't like, my mind just goes there. I was like, I have to consider this now.
Yeah, and sorry, I'm just seeing the link title itself is "Living Things Are Not Machines." Also, they totally are.
Yeah. Also, they totally are, and that's funny in a lot of different ways.
Okay, that is funny. Okay.
I
when the chat came up, all I saw was his actual words, right? Like, I've now come to think that they're,
really?
So I hadn't seen the anyway.
Interesting.
Yeah. But this is cool. So Tuesday, is that the 20th? Yeah. So Tuesday evening, we're doing San Francisco Cognitive Science Reading Group,
Oh,
and which
there's no virtual component to that, is there?
there is. There
Oh.
is.
Uh-oh.
It is late. I can share the meetup link. I will need. I might need to. The guy who runs it. He's a DeepMind guy, but I don't actually have his contact. Like he definitely runs an online piece to this, but I've never actually seen the link, so I don't know how to. Anyway, I just dropped that in the chat, or I'll put. Let me put it in the Slack as well.
The octopus, nice. All right.
Anyway, the yes, you certainly can join. I mean, we're just covering one of the videos in this particular group. Although I'd like to dive into some of Levin's papers are good. I don't want to say easy reads, but they're not necessarily requiring a bunch of biology background or things like that.
I'm hoping to be, well, I don't know how to speak about this yet. I hope to actually finally get to sit down next to Levin and get a chance to talk to him in October at an event here in Boston. And I really like my $1 million question, or billion, or however you want to say it these days, is along the lines of that you've probably seen it. I mentioned it many times. The part of his research paper, the part of his research lab website, where at the bottom he says, like, I want to just ask him, like, what is the motivation and psychology around, like, your advocacy efforts around getting people ready for the ethics behind what it means to fully understand, like, the mind, diverse minds and bodies across things that are, like, we don't even have good frameworks for yet. And I feel like that's, like, I know that's sort of my personal thing, but I just also feel like if Levin wasn't so ubiquitous and doing a bunch of stuff, and I was a little more put together about some things, I'd be like, let's do something very specifically about that, because I feel like that's always an undertone for a lot of things, and it's very well done, because at the same time, I don't want to rock the boat, because I think the way that he talks about it, and there's a very particular, like, strategic, I don't want to say massaging, because that sounds a little bit more nefarious than I mean, but there's a very particular positioning of some things, and I'm like, this is great, and so I don't want to interrupt what he's doing, because I think it's done in a way where he has enough clout and respect for certain things that will just bring people to look at stuff in the ways that it needs to be looked about in some ways. But I'm very curious how that goes, and to go back to your point, yeah, like some of it is very, even the things that he's, like, his blog, which I haven't followed everything on, but, like, he's doing a particular, he's trying to go to a particular direction for things, and I respect the effort that's kind of separate from just the scholarly work, but also, like, very, like, I haven't seen anything where he just comments on this, you know what I mean? Like, that's, like, I don't, like, and this is just where my mind goes about a lot of things, like, strategically, like, what are you trying to, like, and you probably won't say this, like, on the record, but, like, strategically, what are you aiming for, and how are you trying to make how you're trying to advocate or enable certain things that you want to see happen. So yeah. And yeah, you just posted in chat the Platonic space, and I actually mentioned I mentioned this to Addie I don't know if you're in the other Discord. I mentioned this to Addie after you shared it because I was like, hey, Addie, like,
Yeah.
you know, they're trying to do stuff with the Computational Philosophy Club is this new thing that they're working
Yeah.
on.
Yeah.
And it's like, hey, like, check this out. Like we can pull stuff from there to get speakers and ideas from. There's a lot there.
Yeah. I you know, he asked me about it, and I said, you know, I loved, you know, I think I loved it even more to be for Frontier Tower to be hosting the computational philosophy than necessarily Echolopto, just because that's just so well aligned with my own background. So yeah, I thought this was interesting. I was trying to remember. I don't know if Bradley's still here, but there was a meeting like a couple years ago. It was based at UCLA. Michael Levin was one of like 25 speakers, but it had this like incredibly eclectic mix of speakers. And it had a very, it was a very unique meeting. I did not know the organizer well, you know, but after this meeting, you know, I should have memorized their name because it was like such a great collection of people, like a lot of, you know, animal behavior people, a lot of unconventional computing people, a lot of anyway, sorry.
Yeah. I'm not putting my finger on it right now, but
I'll do a dive. But
yeah.
Anyway, there was a lot in this meeting that would be good to follow up on, and I really do, you know, like if they're really interested in you know, getting more empirical and getting more computation, you know, like implementations of computational, you know, would love to really help support that and try and make that happen. Because again, like he's a great meeting organizer. You know, they've got a really interesting network, really eclectic network of people already. And the Aug Lab people have moved to San Francisco too. So I'm working with the same guy, Pedro, the same guy who helped organize the Human Augmentation Summit. Like, you know, I would love to have similar people, the kinds of, you know, BCI work that they were doing, the kinds of, you know, projects they were doing. I've already had a visit from one of the new PhD students at the cybernetic psychology lab at the MIT Media Lab.
Yeah, Pat's group. Yeah.
Yeah. So I think it was Claudia Albrecht.
Okay.
So anyway, I'll check. But I don't want to. Bradley, you've got some papers too to cover, right?
Well, I mean, we don't have to do that. We could, I mean, I can present one paper if you'd like, but.
I always like paper.
Okay, well, we can do one, yeah.
Yeah. To that end, I'll say, yeah, I'm really interested in that. Also, like, I may be helping out local Aug Lab stuff for next year here. Because, yeah, a lot of the people just jumped coast, but there are some folks trying to do stuff next year and all.
Constans Albrecht. Yeah.
Okay.
Anyway.
Yeah, and I know it's kind of the top of the hour, Bradley. I might just do like just a verbal brief update on the Future Center, and then we can talk about papers.
Okay, that's good.
Okay.
really briefly, we made progress on the Future Center. I'm establishing sort of this Future Center of sorts at JoPro, and I'm doing a lot of work on the foundational sort of materials and context and framing and the theory of change and what we want to do, and had a very nice conversation with Bradley recently about like mission, what you want to do, and then also like mission creep, what you don't want to do, and making it coherent and aiming to be rigorous in this and so on. And so that work has been happening. I basically have I have a very simple website landing page up for it. I have a pretty structured set of things I want to do, both like administratively. I'm breaking it down into kind of thirds right now, as sort of what are my goals as like the founding person of this particular center. Is like 1/3 is sort of administrative, 1/3 is sort of actually you could say scholastic, or doing some of the I don't know about research, but the academic framing of what we're trying to do. And then another third sort of I don't know, logistics and the kind of boring stuff, and dealing with other people and trying to make it happen. I have people that are interested in helping out in various forms, which is nice, but it's really much keeping it going forward. And beyond that work, in the essence of staying brief, I had a number of conversations this week with people. It's been very interesting. It's sort of been this sort of intellectual scholarly talk that Morgan's been a part of his other 2 meetings, and now here in Orthogonal. And there's this other sub theme that's been significantly on the nose of really looking at. I believe this week or the week before in this lab, we talked about the. I think it was like an Atlantic or a Time article written by a high schooler saying the discipline, the advent of LLMs has sapped the discipline of doing things in a set time, because you can just wait until the very end and throw it at the machine and something comes out. Did we talk about that, Bradley? I don't remember, but I won't go into it again either way. And suffice it to be, it's led to a number of interesting conversations with some of the interns that I have doing work on AI education and equality, which kind of goes back to the LM conversation earlier today, but also the essence of discipline itself and how do we do that. I think we talked about that. I'm remembering a little bit more. I think we talked about that some. Like can you do it in terms of an aspirational building way? So a lot of the conversations that I've had this week with people in different fields, one of them is someone who's, yes, social workers and things like that, but also people doing academic research, people looking at systemic behavior change and systemic change, and people trying to, like, even some folks from like the plot twisters community who are invested in building, tools of various kinds that facilitate this sense of we could say agency around one's narrative. And that'll be my slight dovetail back into Levin. One of the things that I don't know how to capture and desperately want the video from the Foresight Institute this week is the way Levin spoke about narrative felt so broadly applicable to like plot twisters and other things that I'm in the space of. And I feel like both controlling, like his take on narrative was sort of cybernetically like control, sort of almost like macro. Like you can see the chart with all the parentheses and like negative feedback, goal directed behavior prediction. Like you want like narrative like across that. It's sort of I know that's sort of what he's kind of getting at. But Plotter's is narrativity is much more, almost autoethnographic, phenomenological, internal narrative, which is not really what they're focusing on, but like those are the arenas. And so I feel like there's something between the narrative, between the internally external, and this sort of, identifying problem spaces like the discipline space in terms of how do you build and do things in that space and its relationship to how do you have aspirations that require skills like discipline, but also related to the narrativity of it all. I'll put it that way. So that's super brief and super like teasy, but there's been a tremendous amount of like really nice. There's a lot that's cooking right now, and I feel like my goal is just to stay the course and materialize it. We have this on the screen that I'm still sharing. Like there's this blog post that was really this post was just originally like a capturing of things, and then I like when you look more at some of the quotes from Levin about like he really like what's so cool about this paper, he really juxtaposes himself to Francisco and Humberto Maturana, like and getting at this stuff about, you know, he brings up this again and just where's it going with this. Also, Thomas Fuchs's mention was really cool. I mentioned Thomas Fuchs and Josh Bongard. I'm just saying this now. Bongard was like, oh yeah, like he reacted to it or something. Actually, I think I mentioned it and he liked it and was probably engaging or writing something, and someone else like physically asked him directly a question verbally, and he was distracted because he was replying to this. And I thought it was a cool moment, not because cool for me, but like I would love to have sit down and talk with Josh Bongard more about like Fuchs and organization level stuff. You know, Fuchs is kind of like doing the whole like, well, it's at the level of the organism, you know, and how does that fit with what they're doing, and maybe bringing rigor where Fuchs is kind of trying to kind of outline where to go, but maybe didn't do too much about that. Also, this book, the old book, just because I'm here, this is a book. He was asked sort of how do you what does someone get in this field look at, and he's like, well, I wrote a book a long time ago that's kind of outdated in some ways, but some of the core is still there. So his how the body shapes the way we think, with him and his former advisor Rolf Pfeiffer. And then also mentioning Ludobots again. And that's actually more about that later. But yeah, that's fine. I don't want to ramble too much more. So thank you for brief updates and more. I'll publish this, and I'll publish. I have more things to publish and share about the Future Center at the start of next week. So I'll
throw the mic back and run away after that.
All right, that sounds great. Thank you, Jesse. I think it was a good conversation about this stuff. Definitely submit that post to the Medium, and we'll put that up. And I look forward to reading the final version, and we can go from there. We can look at like what the final version has, what kinds of threads it pulls on, and so forth.
Yeah, I kind of didn't expect to be thrust back into Levin's 2025 take on his conclusion, which was in the chat. I don't know if you got to read it. It's like his base conclusion was like he wrote in chat, and it kind of confused me at first. And I don't know if this was Morgan's reaction. It was confusing because all you saw when I read it after prompting it by mentioning the 2021 paper, Levin said, "I now think that almost nothing is a machine, even machines." I'm like, what? And so he kind of elaborates that in the post, which I'm still processing. So maybe listening to I would love to maybe prepare something for that and talk about it more next time, and sort of this cognition futures revisiting of it. But yeah, there's a lot of like things to pull out there, and maybe I don't know if this is really Vini's alignment or not, but like there's a definite dovetail of like things happening in that direction, or for other folks who want to do something, maybe watching the video and joining the lab too.
Yeah. So the takeaway is that it's machines all the way down, but nothing is machines, not even machines. That's the.
Well, there was this wonderful comment, and I took partial notes of it. Maybe Morgan can remember it, but it was this really nice, and I don't know if it was Levin or Bongard trying to explain something. because it was explained. It was a very interesting comment, and it was like when you're taking apart like a physical being, there's more. It's cells all the way. It's this recursive, not it's kind of the same thing, even if it's differentiated out. Like the stem cells coming up through cell. But when you're taking apart like a car, like it's not smaller cars. It's not. It's these components of. You have an objective in a thing, but like it's not like there's proto cars underneath the thing. And
I mean,
yeah. Please say it better because I couldn't remember.
This was kind of his, it's machines all the way down, but a machine, if you zoom in, you eventually get to like a tire, and it's just rubber,
Right.
and or like the parts are inert, and that's I mean. He went for this kind of like it's machines all the way down. I'd always liked the agential matter, where it's just like it's like that says it all, right? Like
Is that falling out of vogue now? Because I haven't heard that as much recently. But like,
I don't these certainly Michael Levin seems like someone who's awfully online.
Yeah.
and I wonder what that does to his thinking and speaking.
All right. Well, why don't we move on? So as requested, we'll do a paper. So let's do this paper. This is an interesting paper because it's actually from 2020, but it is from a Chinese group, and they're doing this work with Braitenberg vehicles. And the interesting thing about this is that they're basing a Braitenberg vehicle on memristic neuromorphic circuits. So, we think about the Braitenberg vehicle as a toy model and how it's a very simple sort of connection between the sensor and effector, or maybe the light sensors or something like that, in a wheel. So if we have like two light sensors on the front of a vehicle and two wheels on the back, there's a mapping between that sensor and effector. It could be like a cross connection. It could be a ipsilateral connection. It could be, something more complex. And so that's the way we almost think about it as a very simple connectome. And so, but in this paper, what they're doing is they are trying to use a simple memristic neuromorphic circuit because they want to apply this to engineering applications. So again, we went back to Braitenberg's work on neuroanatomy. This was this last summer. There's several features that I did on this where we went through his thinking from like being a neuroanatomist in insect physiology to thinking about how you would simulate a nervous system. And so it was like a progression from his work in the 50s and 60s to this, this artificial sort of biocybernetic approach that he took leading up to his 1984 book and beyond. So this is kind of, where he was coming from. In this case, what they're trying to do is they're trying to develop this memristor that can do basically the same thing, that is, respond to stimuli adaptively, generate behaviors, and provide this mapping from sensor to effector. So let's start with the abstract. The Braitenberg vehicle was a simple conceptual model to characterize the response behaviors of animals or insects under a stimulus. It is widely used to develop autonomous vehicles able to adapt to the varying environments that you see in maybe the world. I mean, in Braitenberg vehicles are very stereotype sorts of stimuli, but you can have all sorts of complex stimuli. And that, of course, would result in even more complex behaviors than we see in Braitenberg's vehicles, as demonstrated in the book. Considerable effort has been devoted to building neuromorphic processors with the software in the vehicles. However, there has been no demonstration of Braitenberg vehicles with neuromorphic hardware so far. So people have actually tried to use or to build neuromorphic processors with software, but they haven't demonstrated it with hardware. So herein a Braitenberg vehicle with simple memristive neuromorphic circuits is built for the first time. This vehicle exhibits adaptive behaviors in the supervised learning process and is eventually trained to conduct the task of tracking paths. So basically, it's trying to train the vehicle. They're trying to train the vehicles to follow or do path following, basically following a stimulus, following that gradient outward, and building a path. Moreover, the memristic circuit in the vehicle demonstrates a very short response latency, and they estimate that at about 56 nanoseconds to input sensory information. Herein, an alternative promising solution is to build self-adaptive robots and pave the way for realization of autonomous robots based on memristive neuromorphic circuits. The introduction is that they kind of go over they review self-adaptive behaviors, which are of crucial importance in varying environments, and it helps animals or insects avoid obstacles. And so they talk about the Braitenberg vehicle being this thought experiment and this toy model, and then they kind of describe that. In spite of much success in achieving autonomous robots based on this vehicle model, the processors of the smart robots are still based on von Neumann architectures. What they mean, I guess, is when people implement Braitenberg vehicles as robots, they generally use a von Neumann architecture to do so. So usually if you have a Braitenberg, a robot that's a Braitenberg vehicle instead of a computer simulation, you're using a von Neumann architecture to simulate this sensor effector mapping. So this is limiting, of course, in the sense that it's maybe not biologically inspired, and it just behaves maybe like any other robot at some level. So what's the point of using the Braitenberg vehicle? So far, the well-known Braitenberg vehicle model has never been implemented on neuromorphic hardware. And so neuromorphic architectures allow for the implementation of dynamic neural control through physical computation. On this architecture, information is transmitted and processed in the analog domain, enabling low power consumption and low latency. Previously, works have shown that various neural networks can be mapped onto memristive crossbar arrays for self-adaptive learning. For the memristive architecture, the non-volatile property and processing in memory improve the energy efficiency, which arises from the ions migration. The advantage of memristive architectures is not limited to energy efficiency. Avoiding the conversion between analog and digital considerably reduces time delay in information transmission and processing. So there's this analog aspect of the stimulus, and it has to convert in the von Neumann architecture. It has to convert it to a digital signal and then convert it back out to an analog behavior. In the memristive case, you don't have that conversion, so it reduces the time delay. This is why they cited the very short response latency in the abstract, because it's basically not doing that step of converting the signal. Considering the aforementioned advantages, it is interesting to build the Braitenberg vehicle with memristive neuromorphic circuits. And so here for the first time, they build a Braitenberg vehicle based on a very simple memristive neuromorphic circuit, which is 2 grayscale sensors, a memristive neuromorphic circuit in the middle, and then motors, which drive the wheels. With a supervised learning rule, the vehicle can be trained to track a path. Furthermore, a very short response latency is achievable for the memristic circuit of the vehicle. And so this is where they're kind of very into the technical aspects of a memristive circuit. But this, of course, we'll go through their figures, and that gives a little bit more context here. So this is an example, of course, of an insect nervous system where you have the compound eyes, you have the brain, you have the locomotor system, and there's basically things are coming into the eyes, being processed by the nervous system, and then being mapped out as movements in the limbs. So you can see that here. And so they're behaving. And that was, of course, the inspiration for Braitenberg vehicles, which you see an example of here. And so here they have, so in A, they have, of course, the ant engaging in obstacle avoidance. So this ant is moving around the stalk here, and it's doing so through this system that I just described. So it's doing this path following. It's able to develop an adaptive path through an cluttered environment. Image B is an electron microscopy image of a 1x16 Memristive crossbar array. So that's here. So this is the hardware that they're using. C is continuous conductance tuning performance on these memristors under the stimulus of electric pulse. And this is the chemistry here, TA205. So this is the sort of the deposition of the layers, the metal layer, 80 nanometers of TA205, which is 10 nanometers, another metal layer, and then the substrate. And then we have in D, continuous, that's the D. Actually, the schematic array was here, and then this is the performance in terms of conductance in D. So they're, given the pulse number, what is the conductance? And then E is model of Braitenberg vehicle, including grayscale sensors, Memristive neural processors, and steering control systems. So this is the setup here is diagram. So the grayscale sensors are here at the bottom. You have the steering control. You have the bio-inspired processor, and it's going forward in this direction. Grayscale sensors are kind of back here, and it's picking up the information, and it's moving and following a path. F is the top view of this assembled Braitenberg vehicle. So here's the vehicle here. The sensors are down here. The wheels are here. This is the processor. The steering control is down here. This is a top view. And then G, demonstration of obstacle avoidance behavior that the vehicle exhibits. So if you can see here and compare with what we saw with the ants, we have this cluttered environment where you have obstacles, and the vehicle is able to get around those obstacles, much like we see with this ant avoiding this stalk. Okay, so they go through the training of the Braitenberg vehicle for path tracking. They say that the locomotion mechanism of the Braitenberg vehicle is determined by neuron interconnections. By changing the connections, the Braitenberg vehicle exhibits different and complex behaviors under the same stimulus. Therefore, the capability of learning and adapting to the varying environment is crucial for the practical application of this. So in figure 2, they show a flowchart to illustrate how a supervised learning process is performed in the Memristive neuromorphic circuits. The weight in the artificial neural network would be updated according to the punishment or reward feedback instructed by the supervisor, which is based on different response behaviors of the vehicle to input signals. After a few iterations of the feedback loop, a new mapping relationship between the input signals and the output signals will be established, which indicates that the vehicle acquires a new skill. So they have this whole training regimen where there's the supervisor, and it's giving this sort of reinforcement learning approach to stimuli and to encountering stimuli. So when you encounter a stimuli, the supervisor looks at the weights, it gives feedback. The feedback is either positive or negative. The negative is punishment, the positive is reward, and then this allows us to have these different mapping relationships over time that change the behavior so it can follow this path. Traditionally, weight update process of the Memristive neural network is controlled by the software in a digital controller, such as a personal computer or a microcontroller. So we have this, this weight update process. It's going on kind of separately from the navigation, and it's just kind of giving feedback. Note that we have implemented neuromorphic neural networks in the vehicles using Memristive crossbar arrays. On this neuromorphic hardware, we update the weights in the artificial neural network through a simplified method without using the traditional digital controller. So they describe this process in a von Neumann architecture, but then they describe it in the neuromorphic architecture. So they go through the weights here and kind of how this is done, all the methods here. So this is figure 2. So A is a flow chart of this process. We go from the environment. Information from the environment is captured by the sensors. The sensors then pass this to the bio-inspired processor, where you have the simplified neural network where you have afferent neurons, this memristive arrays for synapses, which just map the afferent neurons to efferent neurons. The afferent neurons take in information from the sensors. The efferent neurons are the output layer that map that to the motor control of the vehicle. And so the WIJ matrix is just the mapping between those. And those weights then of those connections are sort of given feedback by the supervisor. When the weights are positive, they give positive feedback. When they're negative, they give negative feedback. And negative means basically you're headed towards an obstacle. Positive means you're on a path that avoids an obstacle. And so then that leads to motor control. Now figure 2b is the detailed circuit diagram of the Braitenberg vehicle. So this just describes this as a circuit. So we have grayscale sensors, 2 grayscale sensors. We have the battery, a driving engine, and the pulse generator. The grayscale sensor is mapped to this internal supervisor. So this is where you have this sort of much more coarse grained map that we can follow that basically gives the feedback signal. So it's either positive or negative. That's why we use this 2-bit grayscale sensor. And then we have the pulse generator, which generates information from the environment. This goes into this network. The supervisor evaluates the network and provides feedback. We have the reward feedback and the punishment feedback. So we have, that's a binary value that goes into this network. The device selector is learning mode 1 and working mode 0. So it's either going without learning or it's actively learning. And you can switch between the two. And then there's the steering engine and a differential amplifier. So once this network is supervised and given the proper feedback, then it goes through this differential amplifier. This oscillator is added to the generator, and then this is giving the steering engine, which gives you the motor output. Okay, so that's basically how that's structured. This is figure 3. This is a demonstration of learning process again. This is where this graph in A is where we go over time, and we have the normalized weights of each connection, 1 positive, 1 negative, 2 positive, 2 negative, and this just shows the normalized weight of that. And this is, I guess, normalized by, I don't know, from 1 to 0, I guess, or 0 to 1. And then, so our iterations here, we see that over time, we get these weighted, or these normalized weights. So the positive is positive feedback, the negative is negative feedback. And so we have these graphs here which show over time that it's learning from the environment. And then we see the behavior of the vehicle. So in iteration 0, the vehicle travels in a straight line even though it's supposed to make this curve. It doesn't make the curve successfully. In iteration 24, it's learning how to make a curve, but it doesn't make a curve successfully, or at least 2 curves successfully. It kind of makes a curve and then goes off on a tangent. And then finally, by iteration 37, it is able to learn this course, where it actually needs to make 5 or 6 curves, I think, to make it all the way around the circuit. So to recap, iteration 0, it learns nothing. It's just operating on input-output. In iteration 24, it's partially learned how to make curves, how to make turns, but it only knows how to make the 1, or actually 2 turns, but only knows how to make that curve, and that's it. And then by the iteration 37, which isn't that much time from iteration 24, it manages to leverage that knowledge of curves, or that ability to curve, into making multiple curves to follow the path. And so then this is just the gray value at the left sensor, gray value at the right sensor. So the differential learning between left and right. and you see that there's this difference over time where you get this iteration 0, it's basically random. Iteration 24, it's kind of figuring out a gradient, and then in iteration 37, there's this sharper gradient, which allows it to do this sort of behavior. And so then, yeah, they kind of give this overview of the Memristive circuit and the different inputs and out, or the different input values and that sort of thing. Remember, this is an analog system, not a digital system. And then, of course, they show the difference between the Memristive neuromorphic circuit and a digital von Neumann circuit. The analog domain is where the environment is, and when you use a von Neumann circuit, you need to do some sort of analog to digital conversion, and then process things and then go digital to analog for the response behavior. But in a neuromorphic circuit, you'd use parallel processing, not serial processing, and you keep things in the analog domain. So there are two benefits to that. Okay, so that's all there is for that paper. I thought that was an interesting paper in terms of like the technical aspects, but also sort of the larger aspects of, we were talking about analog sort of simulations of the nervous system. And that's kind of one example of how you might do that.
Yeah, actually trying to add neurons.
Yeah.
Yeah. That's cool.
All right, thank you. That was a great paper. All right, so I think we can end for today. Thanks for the conversations, and let's follow up and see you next week. Yeah.
Let's follow up on Slack.
All right, thank you. Bye.
Take care.
Take care.
Bye.
Bye.